So this was the first one we did. It's the golf bag problem. So you have the standard bag, deluxe bag, and here's the work that needs to be done, and how many hours are needed for each bag, and how many hours were available to spend on these two bags, and here are the profits per unit. So we kind of put this all together and formulate a model like this, right? So remember this, right? So maximum profit, 10s plus 90 and subject to, and 710s plus 1. So we just kind of went down, and so here was the amount used. So cutting and dyeing hours. Here was the amount of hours that will be used if you make S units of standard bag and not D units of deluxe bag, right? So S and D were the units or number of bags to produce, different, the standard and deluxe. And so remember what this meant. So because that's important, right, to formulate it and then interpret it, to solve it and interpret it. Okay, so we got, here. Here the steps are, so the first step is you're going to put it into Excel, like the numbers and the formulas from the model, you're going to put into Excel. And then the second step is you are going to solve the problem. You're going to solve the problem by calling up Excel, calling up Solver. So Solver is an add-in, and it's like a data analysis tool pack. And so you go to the same place. So go to the Data tab, and then you click on Solver. And if you don't see it in the Data tab, then you're going to load it just like you loaded the data analysis. Okay, and I think I also put some instructions here, right? So here's the Excel for Mac. Okay, so same way, same steps as in the data analysis. And here's the Excel for Windows. So why don't you guys take a minute to load Solver and make sure you could see Solver in the data tab here. So we're going to create this. This is already done, and of course, we have to do it ourselves, actually, to learn how to do it. So what we'll do is we are going to kind of I guess we'll make a copy of it, and then we are going to delete a bunch of stuff, and then just recreate what we deleted. So we're going to make a copy of this, and to make a copy of a sheet, you would do a Control or Command, depending on whether you have a Mac or Windows. So hold down the Control or Command, and then just kind of, drag it, drag the tab, and then let go where you want it. And then that copy is going to now be there. And so I already had the A2, so my copy now is named as A3. Okay, and we're gonna keep making a bunch of copies here. So make sure you could do it with no problem. And of course you could always go over to right click and then move copy, and then to create a copy that way. Okay, so I'm gonna just go here, A. Okay, and then A3. That's going to be my original, and maybe I'll just say here, this is the original. Okay, so it's good to have a copy, and so that we could look back on the original as we work in case we make mistakes. So we're gonna go over here. Okay, so now remember, this is your linear programming model, and remember what we did last time. We did something like this. Okay, so we did some Excel work last time, right? So we made this cutting in. So here are the constraints. Here are the numbers from the constraints, and then here we did and then we had a standard bag, deluxe bag columns. Then we had the profits per unit, and we use this kind of little formula to make the left-hand side amount that is used, right? And then we did less than equal to, and then the right-hand side. So this was the left-hand side, and that was the right-hand side. And here we had all these coefficients. All these coefficients were put in like a little table kind of format like this. So we're going to do the same kind of thing. So we're going to take all this and then delete all these. but leave the labels so that we don't have to copy them. We don't have to type them over. So here we're going to kind of just fill in all these things. So as we fill this in, I'm going to explain what we're doing at every step, so we know exactly what is going on here. Okay. Now let's go over to here. Okay. Okay, so this is what I just showed you, and here are the steps. So here are the steps that we use to create this part. So basically, we're following the steps, but I'm going to do it with you. Okay, so we have the headings. So we have the headings. Okay, what is this thing? And we have the headings, the row headings, like over here, and column headings over here. And then we're going to enter the coefficients for the objective function. And that's over here. And then also for the constraints, that's going to be over here. So so we are starting out, with the linear Poisson model. So we already have the model, and now you're going to kind of transfer this information into the cells of Excel. Okay, so we're going to go over here and say 10, and then 9 for the coefficients. And please make sure you do it along with me, right? And so because you'd have to do it yourself to actually know what to do, when you have to solve your own problem. Okay, and cutting and dyeing, so it's that 7, 10, 1. So that's 0.7 and then 1, right? And then this must be 0.5 because it's 1/2. So put down 0.5 there. Now for this one, it's 5, 6. We want to avoid round off errors, because if we do, if you say 5 divided by 6, you get 0.833, and then 3 just keeps, it continues on. And you don't want to round it and put it here, because then we're going to lose some accuracy. So here also you want to use you want to kind of state it like equal to the fraction. And then now the finishing is a 1 and a 2/3. So we're going to put here 1. And the 2/3 is the same thing. 2/3 is going to be like 0.66666, so forth. And we don't want to round it too soon. So we're going to just do 2 divided by 3. So we're going to say equal to, and then put the fraction there. Okay. And the inspection and packaging, that's a 1/10. That's just a 0.1. And quarter, 1/4 is 0.25. So I don't have to say equal 1/4 because I already know, but we could just say equal to 1/4 is fine too. So we could have, okay. So we have the coefficients here, okay. And then, so what did we do so far? We did all this, and we designated a location where the answers should be stored. So our variables S and D, so those quantities, we need to decide on which cells are going to store these. Well, I already decided for you, so just keep it that way. So we're going to use these cells, B4 and C4, for the S and D. Okay, S and D. So these are going to represent the values S and D. So these are called variable cells. So these are called variable cells because, well, S and D are variables. Okay, and now designate a location for the objective function value. So that's going to be D6 in this case. So objective function, remember, is this part, this thing that you're trying to maximize here. So this cell is going to hold this function, 10s plus 9d. Okay, so now you want to type this, sum product. So remember that here we could do, before we did something like this, you could say this number times that number plus that number times that number. And that's going to represent this formula, 10 times S plus 9 times D. But now we're going to try to be more efficient and use a sum product function for this. So remember, the sum product just makes you give it 2 ranges of cells, and it's going to multiply, and then add them all together, which is exactly what we're doing here. And so what we'll do is now we're going to use sum product function. So we're going to type sum product. Then we're going to choose the coefficients, 10 and 9, and then comma, and then choose the solution cells like this. Now, it might be good to put some numbers in here so that we could see the result of the calculation. Like we tried like 100 and 100 before, and so let's try that. 100 and 100. Okay. Put here. 100 and 100. You don't have to think of a really good numbers to enter there. So these are just there as placeholders. Okay. So that gives me 1900. So that makes sense. Okay. And then for the left-hand side, so all the left-hand expressions, so these are similar expressions like this. So we could just keep using the sum product function for all these expressions, on the left-hand side. So that's what we're going to do. So this is what you're going to enter. And so here you're going to say sum product. Okay, so you pick the coefficients like 0.7 and 1, and then comma, and then pick the solution cells or the variable cells. Now we want to copy this down. Right? Because we're going to use that's the same expression for everybody here. So we'll just copy this down. So in order to copy this down without getting into trouble, what do I need to do here? The dollar signs? Right. So F4, right? So you go function F4. Okay, so we got the dollar signs here. Okay, so this should look like this, right? So it should look like this. And then you want to copy it down. Then you copy this down to here. Now you have the left-hand side expressions. And it's always good to check that it worked. So you might go to the last cell here and then just double-click on it to make sure it's referring to the correct cells in the function. Okay, so that's the left-hand side. That is the left-hand side. And then here we want to do inequality signs. So less than or equal to 1, 2, 3, 4, all these are less than or equal to. And so I might just just copy it down, type it once, and then copy it down. Okay, and then the right-hand side values, just enter these values. You see, so 630, 600, 708, and 135. So just copying these down here. So what I've done is I put my data here. So the coefficients that we were given, I put them here. And then this is going to hold my solution. Right? So I just put some numbers in there as placeholders. But eventually, after I solve the problem, solver will give me the optimal, the best solution, and put it in here. Okay. And so here's the setup. So this is these are the constraints. So right here's the left-hand side. So that's these cells. And the right-hand side are here. And the inequality signs are here. So these cells represent the constraints. Now, these are just the data, the coefficients that are given. And I'm using them in my constraints, with that sum product function. Okay. And then what's next? Well, let's take a look at what we should do. So we entered the right-hand side values. Okay, now it says step 7, it talks about the slack values. Right-hand side minus the left-hand side. So this is what it says you should do. So F8, or G8, so go over here. And then you say right-hand side value minus the left-hand side. Okay. Well, what is this? This is additional information that's useful to keep track of. So here we are kind of keeping track of how much will be left over. And so remember, like here, each constraint represents a limit of some resource. So here, the cutting and dyeing. Here's how much you're using. And here is the available amount of the resource. So if you look at this, so this is saying that if you make 100 standard bags, and 100 deluxe bags, then you're going to use 170 hours of cutting and dyeing. And there were 630 hours available. So there's actually a lot of slack here. There's a lot left over. So that leftover amount is what we call slack. So it's the difference between the left-hand side and the right-hand side. So if I take the right-hand side and subtract the left-hand side, that is the leftover amount, because it's the available amount minus the amount that is used. Okay, so slack is right-hand side minus the left-hand side represents leftover amount for a resource constraint. Okay, so here it says there's 460 hours left over if you make 100. So if you make this decision, then you're going to have a lot of leftover amount hours that are here. So which means that in cutting and dyeing department, there will be a lot of people that are just sitting around, not having work to do. They may be surfing the web, looking at their phone, and so forth. And so you probably want to make more, okay, not just make 100 and 100. Okay, so let's now copy all this down as well. So you can see, like, in each department, you have some slack. So a lot of people with a lot of free time on their hands. Okay, so we want to now increase these numbers. We want to increase these numbers and make these, put these guys to work. Okay, and so our goal, remember, is to maximize the profit. You want to maximize the profit by making good use of your resources. And so you got to decide how many of this and how many of that to make in order to maximize your the total profit. Now you have the spreadsheet model of the linear programming problem, and then let me also show you in terms of picture what's going on. So here's a picture. Here's a picture of what is going on. And so remember that we talked about feasible solutions before. All right, so feasible solution means that it satisfies all the constraints. So left-hand side are less than or equal to right-hand side. So then you have a feasible solution. And 100, 100, that's a feasible solution. And we also came out with some other feasible solutions last time. So, right, so like these are some feasible solutions that people found. And so here are some profit values from different feasible solutions. So there are a bunch of different feasible solutions, but what we want is out of all the feasible solutions, we want to find the best one. And what do we mean by the best one? Here we're talking about the one that gives us the highest possible profit, while still satisfying all the constraints. And so here you could see like number of standard bags. So that's the S values here. So S values go on this axis, and D values are on the vertical axis. Okay. So when we say 100 and 100, when we talk about 100 and 100, so that's this part. So 100 and 100 is over here. So it's feasible, right? So it's inside the feasible region. And what about the let's say 400 and 350? 400 and 350. So that's over here. And 350, this is about 300, so 350 might be about here, something like this. So that's another feasible solution. And so these are the solutions we thought of, so these should all belong in here somewhere, feasible region. So out of all these, we're trying to find the optimal solution that gives us the highest possible profit. So now what we're going to do is we are going to solve this problem. So let's look at what we're doing. How to access Excel solver. We went through that. So everybody now has a solver. Okay, so here's what we're going to do. So you're going to go click on solver. And so we're going to go to data, and then click on solver. So you get a dialog box like this. So right, it looks like this one. So you get a dialog box like this. Okay. Now, but you can see that there's things filled in. There are things filled in here because I already filled this in. I already solved this before. But again, to learn how to do all this from scratch, we're going to take all these out. So we're going to say reset all. So click on reset all, and then say OK. Now you have nothing. And also, if you actually if you are like starting a new problem and you bring up solver, it's going to look like this. So this is not going to be checked, and this is going to be set over here. So this is what you actually see. Now what you're going to do is you're going to fill in the objective, variable cells, and the constraints. The three things we were talking about. So decision variables here, and here's your objective, and here are the constraints. Okay, so let's kind of do this one at a time. So we're going to go over to the objective and just have to tell solver where it is, which cell has your objective. And which cell is it, by the way? So objective is this one, the blue one. Yeah, that's just one cell thing. That has like a total profit or total cost or whatever it is you're trying to maximize or minimize. So you're going to click on this, just click on it, or if for some reason, if it doesn't let you click on it, just type D6. Okay, that, and then you want to maximize it. Is that right? Right, profit? You want to maximize. So let's leave that alone. And then go over to variable cells. Then we're going to select the B4 and C4 together. So B4 colon C4. B4 colon C4. Okay, like this. Okay, now what about the constraints? The constraints, can I type the here? No, you have to actually click on add button. So to put anything here, you have to go over to add. So we're going to go add. Okay, now here we're going to say, here's the left-hand side, here's the inequality, and here's a constraint. So I might go, okay, cutting and dyeing, that is here's the left-hand side. And then less than or equal to, okay, so we'll just keep it at less than or equal to, and then constraints, we'll select the right-hand side. Okay, so so that was the first one. So normally I might do it one at a time, and kind of like this. So I do the first one, and then I go over to add, and I go to the second one, and then go over here, and then add, and this one, less than or equal to inside, and then add, okay, one more. Okay, so I'm just going fast because I don't expect you to do this. I'm just showing you a kind of long way. Okay, so then here are my constraints, like one at a time. But actually, if you have a same type of inequality, kind of connected like this, then you could do them all at once. And so instead of doing it this way, we're going to just delete these and show you the way to do it just with one step. So let's say add, and then we're going to just select all the left-hand side expressions, and they less than or equal to. Here we're going to select all the right-hand side. So we're going D8 through D11, then F8 through F11. Say, okay. And now I got this, D8 to D11, blah, blah. Okay, so those are the three components, right? And now, what about the non-negativity? Like this part we didn't discuss before, that the variables have to be non-negative. So that one I could specify just by checking off this box. So make unconstrained variables non-negative. So this is equivalent to this non-negativity. Okay, and then select the solving method. So here it says GRG nonlinear. That doesn't sound right because this is supposed to be linear programming, right? So linear programming. So don't select this and select the LP. LP, that's linear programming. So simplex L stands for linear. So choose this, simplex LP. Okay. Okay, and then I think that should be it. Okay, are you ready? Are you ready to solve this problem? Okay. Okay. So let's see. So, well, there it is. So it's very quick. So it says solver found the solution. That's good, right? Now you could see that, you have some different numbers here. So it automatically entered the optimal solution here. So this is the best one. So now I know what to do. So it tells you what to do. Okay, here's what you should do. So the best course of action is to produce 540 standard bags and 252 deluxe bags. Okay, so this will give us the highest possible profit. And what is that highest possible profit? That is $7,668.